Alright, so what I've set up here is a little model to kind of explain a little further about our defrost process using a defrost time clock. And you might find this in a reach-in freezer or a walk-in freezer. So let me go over some of the components you might see in those examples or those systems. So here's our evaporator fan motor. Of course, we got our defrost time clock control. We have a thermostat here. We have a red light bulb. This light bulb is representing our, let's say, defrost heating element. That's why it's red. We have a clear light bulb here, and this represents our liquid line solenoid valve coil. And the valve itself is not in here, but the valve basically, if it opens up, it allows refrigerant to flow through the system. If the valve is closed, it stops refrigerant flow. So, and the way that happens is if this coil is either energized or de-energized. So if the light is on, that means that the coil is energized and the valve is open, allowing refrigerant to flow. If it's not on, basically refrigerant flow stops. We have a DTFD control, which is this little switch indicates a defrost terminate / fan delay thermostat control. The purpose of that basically is to allow the fans to not come on until the evaporator temperature drops, and once it drops, that switch closes and then the evaporator fans will come on. It's got another thermostat within it, and that's the defrost terminate portion of it. When that thermostat temperature rises to the point where it closes that side of it, it's going to energize a coil which is located behind our defrost timer, which I may have mentioned in our previous videos. If that coil is energized, it's going to trip the defrost clock out of defrost if it's in defrost. Okay. And then here we have a little light switch here. This is basically representing a thermostat, and if the temperature rises to the point where it gets too hot, it's going to kill whatever it's in series with. So this here basically is our heater limit switch. So if the heaters get stuck on for any reason, that temperature of that thermostat starts to increase, and when it closes, when it opens, it's going to kill the heaters as a safety precaution. Let's just say, for example, the defrost clock gets stuck in defrost and it just doesn't work and the heaters stay energized. Well, we need a safety control to take that out of the circuit. So we have basically our heater limit control. Alright, I put together here a basic diagram of it. So this here, we got our L1, L2, our power supply representing 120 volts. Here's our defrost timer terminals. We got N14, a blank terminal, 3, 2, and X terminal. As you can see here, those are all listed down here. We have a thermostat, which is this. We have our clear light bulb, which I told you earlier is going to represent our liquid line solenoid valve coil, which is this. Our red light, which is basically our defrost heater. Our motor, which is our fan motor. We got the limit switch here. What else? Oh, our DTFD. This is the thermostat that closes on temperature rise and closes on temperature fall. Okay, and then of course, our power supply here. So let's go through it. I'm going to plug her up and kind of give you an idea of the function of it. So right now we have power, and as you can see, our light bulb is energized. The light bulb represents our coil that's energized, and if you look at our circuitry here, I'll show you how that works. Alright, so looking at their diagram here, we have power going from L1 to our clock and L2 going here, and as you can see, power is fed between 1 and 3 and 2 here, which represents that bar there. Our timer is not in defrost, which means we're in a normally closed position, so these two switches are closed. And since our light is working here, that means we have power leaving our in wire here, which goes to our thermostat, which is this. That feeds the light bulb circuit. And in order to make that work, it has to go back to our L2 side. So we'll take that and just run it down to back to our L2 side there. Okay. So this is our circuit for our clear light bulb going through our defrost clock. So L1 once again through here, through our normally closed switch. That feeds power to our thermostat, energizing that light bulb coil. And then of course coming back to L1, L2, which completes our circuit. Light bulb is on. Okay. If we were to put this thing into defrost, let's try it again. I think I missed it. Okay, so what just happened there was this switch now opens, which now this light bulb is off. Now our normally open switch closes, and that is now energizing the red light bulb circuit, and that goes through our limit switch. And again, our limit switch basically should open up on temperature rise, and so it should be like this. So if the light bulb, if the defrost heater gets stuck on, that temperature should rise, causing that limit switch to open, killing the circuit power to that defrost red light bulb, and that should turn it off. And of course, in order to make that circuit work, we have to go back to L2, which this does. Okay? So once the defrost has completed, either by time duration in the middle or by our defrost terminator, then defrost will end. So we're going to advance this. It's just based on our timer. So we're going to turn this, kick it out of defrost, and now our defrost terminals have opened back up, and our normally closed switches have reclosed. Okay. Alright. Since now this is back on, we're back into normal freeze mode. But if you notice, this defrost timer has two normally closed switches. So this switch is closed here, turns on our light here, this circuit. And now this switch closes, which represents our fan motor circuit. So we'll put that there. We'll put this over here. And this is our DTFD thermostat control. And this is going to go back to L2 to complete that circuit. Okay? So if we follow the circuit right now, we can see this L1 feeds through here, through our defrost time clock, through the normally closed switch, through terminal 4, to our fan motor. Fan motor is not running. So let's follow that circuit along. It comes through our DTFD, which is represented by this control here. And if our compressor and our refrigeration system is operational, our evaporator should be getting cold, which means our temperature here should be picked up at the thermostat, and the thermostat should be starting to close, or getting ready to close. That temperature is going to fall, and when that falls and makes this circuit here, that closes, then that circuit gets completed, and that completes our L2 circuit. So let's do that. So temperature falls, thermostat closes. And of course now our fan motor is operational. Okay? So now we're in basic refrigeration operation. Compressor, refrigeration system's running, fan motor has come on, our liquid line solenoid valve coil is energized, allowing refrigerant flow to happen. Everything's working normally. Alright, so once again, let's put this thing back into defrost. by the way, this does it automatically. Okay, so what happened here now is our switch, our normally closed switches on our defrost clock has opened, and we have now closed our normally open switch, and that feeds this red light. The limit switch is closed. That comes back to L2, and we have a red light running, or a defrost heater running. Okay? Now, one thing I may have mentioned to you guys earlier on, once again, is behind the scenes here we have a solenoid coil behind it. If it is energized, it's going to kick this thing out of defrost and open our normally open switch and reclose our normally closed switches. Okay? Now, in a diagram, it's basically getting power behind the clock from our normally open switch. So I'll just do that by dashed lines representing wiring behind it. Okay? And that goes to the coil, and then that goes back to this piece here. Okay? And it's gonna, this wire is gonna hook up from our blank terminal here to our other side of our defrost terminated or fan delay control switch. So we'll put that like so. Okay? So right now we're in defrost. So we should be heating up the coil. This thermostat is located in the coil. So our temperature will start to rise in our thermostat going up, and when it goes up, it's going to close that circuit. When it does, it's going to complete this circuit here. So right now this is considered L1. It goes to our coil. To complete the circuit, it has to go through here back to L2. If the thermostat is closed, it completes that circuit, energizing this, and it should terminate defrost, opening this circuit and reclosing the normally closed switches. So let's check it out. So temperature goes up, temperature's rising, thermostat made the switch, which energized our coil behind the clock, which kicked it out of defrost, even though the clock may show that it's still in defrost. Okay? And now our light bulb back on over here represents our coil to our valve. Now it's energized, refrigerant flow should be flowing, our compressor should be running, the temperature in our refrigeration system in our evaporator should be dropping, and when that starts to drop, our thermostat here located in our evaporator will begin to drop, and then it'll close this circuit here, and then on comes your fan. So that circuit got completed.